Hey guys, it's Mrs. Koblitz here, and today we're going to be learning about zeros of a function. So, we should probably discuss what are zeros of a function. Well, graphically, so that means if you're looking at a coordinate plane, it's the points at which the graph crosses or intersects the x-axis. So it's wherever the graph, the line, crosses the x-axis. Sometimes it'll be in one place, sometimes it'll be in two places, you'll see. So it's wherever the graph crosses or intersects the x-axis. And remember that x-axis is the horizontal axis on the coordinate plane. Algebraically, we can also identify what the zeros of the function are. All you'd have to do is plug in 0 for the f of x, or a y. So algebraically, it's the point or points at which f of x equals 0, with the y equals 0. What are they also called? Sometimes we call them the roots of the function. Sometimes we call them the x-intercepts, because obviously it crosses or intercepts, just like intersects, the x-axis. And we also call them the solutions. So take a second and copy that down. Feel free to pause the video if you need to. But let's try to identify these given a graph. So again, our major thing here is we're going to want to look for that x-axis. Okay, wherever that line crosses the x-axis. I just wanted to blow it up a little bit so we can see better. So just to make sure you realize which axis, this is our x-axis. So this is where we're going to be looking, where the lines cross. So all right, here's our x-axis. I'm just going to go along. Right there is where it crosses. So if this was my origin, if right here was my origin, so that's 0, 0, I know when I go to the right of the origin, I'm going to be going positive in my numbers. So I'm going to go 1, 2, 3, 4, 5, 6, 7, okay? So you say x equals 7. This line only crosses the x-axis one time, so we'll only have 1, 0. 1, 0 of this function. Let's look at number 2. Here you see a parabola, all right? So obviously it's crossing this x-axis in two different places. It's going to be right here and right here. So if I step back just so I can see where my coordinate plane is, I believe right here. So now if I go to the right one, to the right, and that's going to be x equals 1. From here, I'm going to have to go to the left, 1, 2. All right, so x equals negative 2. Let me write that a little bit neater over here. All right, let's look at number 3. And again, looking at your notes or being able to zoom in on your iPad or whatever would be much more helpful. I know it's kind of hard to see when you're at the board for me, so whatever works best for you. So here's our origin, just so we can see that. Our line crosses the x-axis right here. So from the origin, I'm going to go to the right, 1, 2, 3, positive 3. So x equals 3. All right. Here's the origin right here, just so I can reference it. My line crosses the x-axis right here and right here. Let's start with the one on the left. So from the origin, I'm going to go back. So I'm going to go back 1, 2, 3, 4. So my x would be negative 4. From the origin here, I'm just going to have to go the right 1. So x would equal 1. Let's look at some more. Two more on that front there. Let me clean this off so we can see. All right, another parabola for number 5. You'll really be working with these when you get to Algebra 2. I'm going to go from left to right. And wait, here's my origin, left to right. Here crosses the x-axis. Here crosses the x-axis. So from the origin, looking at this one, I have to go back 1, so x would equal negative 1. From the origin, I'm going to have to go to the right, 1, 2, 3, 4, 5. So I know x will equal 5. Uh-oh. We're going to have 3 roots to this one, or 3 zeros. Roots, in other words, Another way to say it. So from left to right, I'm gonna go across the x-axis. I see there, and right here, and right here. I also notice that that's the origin. So going from the origin, I'm gonna do this one first. I have to go back 1, 2, 3, 4, 5. So this is gonna be x equals negative 5. I don't have to go anywhere here, so x is going to equal 0. And then from the origin, 1, 2, 3, 3 to the right, so that's a positive 3. Also, many times you'll see these written in a bracket. So for example, you could see x equals, and then you have your bracket, especially if there's more than one root, negative 1, comma 5. With 3, it's definitely common to see those written in bulk. So we have negative 5, 0, and 3. All right, let's continue. There is another way to identify what the zeros of a function are. We're going to talk about that now. So on the front of this note sheet, we talked about saying the f of x equal to 0. And that's exactly what we're going to do here. But as our steps that I want to write, we're going to write set the function equal to 0. That's our first step. Set the function equal to 0. Our next step will be to solve. So I told us to set the f of x equal to 0. So there's our f of x, also known as a y, but this is function notation. So we're going to make that a 0 equals 4x minus 8. So first step, set it equal to 0. Next, we just have to solve. I'm going to add 8 to both sides to try to get this x by itself. Over here, it cancels out, and I know that 8 plus 0 is going to give me 8. Bring down everything I have left over. The next thing that's attached to my x is that 4. When they're touching, I know they're being multiplied. So to undo that multiplication, I'm going to need to divide. 8 divided by 4 will give me 2. There we go. Number 8. That f of x, I'm going to have to set that equal to 0. Bring down everything else. Again, we're going to want to get rid of that constant term first. So I'm going to subtract the 2, giving me negative 2 equals 2x. And when I divide by 2, to isolate that x, to get it all by itself, I know that negative 2 divided by 2 is going to give me negative 1. So far, so good. Again, we're going to set that equal to 0 and solve. I always like to put in a 1 just so I remember to divide at the end. I need to subtract my 7 from both sides. Over here, it's going to go away. I'm going to get negative 7 equals negative 1x. Then I know I have to divide by negative 1 to get rid of it. And x will equal positive 7. One more over here. 0 equals 2/3 x minus 6. Just going to solve that through. Add 6 to both sides. 6 equals 2/3 x. Instead of dividing by my 2/3, which you can do, I'm going to multiply by the reciprocal. The 2/3 and the 3/2 are going to cancel out, leaving me just x. And 3 times 6 is 18. 18 divided by 2 is 9. So x will equal 9. So far, so good on those. Let me move my last examples up so I can have some space. We are actually going to stop after number 11. So let me move it down a little bit, because we're not going to learn how to do the graphing calculator because we don't have graphing calculators. And in Algebra 1, we really don't need them. Neither do we need them in Algebra 2, really. So we're just going to cover 11 and 12. Once you get to Algebra 2, You will be working with parabolas and you will be working with zeros of a function and you will be working with graphing calculators, so you'll be able to do this. Again, let's set this equal to 0 and solve. Let's subtract our 2, giving us -2 equals 1/2 x. And instead of dividing by 1/2, I'm going to multiply by the reciprocal, which is a +2 over 1. So -2 times +2 would give me a -4. Last one here, 0 equals -2/5 x is 4. Gotta get rid of that constant, that 4. -4 equals -2/5 x. I'm going to multiply by the reciprocal, which is -5/2. Keep your sign. This cancels out with this. I'm going to be left with x on that side. A negative times a negative is a positive. 5 times 4 is 20. 20 divided by 2 is 10. And we're all set. Thanks so much for tuning in, guys. See you soon.